We now move on from the topic of kinematics quantities to motion graphs. So motion graphs are graphs that we use to show or to describe how an object changes its displacement, its velocity, its acceleration with time. Okay, so we are going to learn three types of motion graphs, namely the displacement time graph, the velocity time graph, and the acceleration time graph. Okay, so if I say displacement time graph, then it means the y-axis will be displacement, the x-axis will be time. As shown over here, you have your displacement, which is represented by a symbol s and a unit of meter. Whereas on x-axis, you have your time represented in the symbol of t with a unit of second. So this is the axis for displacement time graph. Okay, as you can see here on the y-axis here, it's labeled s. So s, as we usually know, it's the magnitude of the displacement s. Okay, it's the magnitude of the vector displacement s with an arrow. If you remove the arrow, then it's magnitude, right? Okay, so since this is magnitude of displacement, so magnitude of a vector must always be positive, right? So if magnitude of a vector must be always positive, does this means that for our displacement time graph, all the displacement that we plot must be above this x-axis, because displacement magnitude must always be positive. So does that mean we must plot everything above here, cannot access anything below here? Well, not really. Okay, here's one thing that we always don't think that is really important, but I'll sadly talk about it. Okay, when we are plotting displacement time graph, right, we are actually plotting not the magnitude of the displacement. What we are plotting here is the x component of the displacement against time. Okay, if I'm moving in the x component, then it's the x component of displacement against time. So if I'm plotting the x component, now if the displacement is towards the right or towards the positive x direction, then you'll be a positive value up here. But if the displacement is pointing towards the left or pointing towards the negative x direction, then you are able to access the negative region over here. Okay, so just a little note, what we are plotting here is the x component of displacement time. And of course, if it's an object moving in the y dimension, then this one will be sy. Then if you're plotting something above, then this displacement is above the initial position. Okay, the displacement is pointing upwards. If you're plotting something down here, then it means the displacement is pointing downwards. Okay, we're plotting the y component. But if you're plotting something which is a 2D motion, let's say you have let's say motion in 2D, then you have x dimension and y dimension, right? So what you need to do is you need to split your graph. You have to draw two graphs for displacement, one in the x direction, one in the y direction. But that is not within our syllabus because our chapter here is called Kinematics of Linear Motion. Linear motion, one dimension. Therefore, we only draw motion graph for one dimension only. Okay, so that's a rough overview. Let's move on. Okay, so yeah, this is the same displacement time graph. You change it to x component of displacement, x component velocity time graph, x component of velocity, acceleration time graph, x component of acceleration. We change everything to components. And of course, if you see in books there's no x, it's not that they are doing magnitude. It's just that they omit the subscript x because they think it's straightforward. Okay,